All right, so we're going to have a little shorter notes and a little shorter homework today because we're only going to do the first part of 10.3, which is going to be how we start doing some operations with radicals. By meaning that, I mean adding, subtracting, doing a little more multiplying, that kind of thing. But again, let's see, what's today, January 7th, and a little bit of review for the final before we start. How do we solve an equation that's already factored like this? The easiest thing, you might say, oh, I'm going to FOIL it. You don't want to FOIL it because you're looking to solve it. So I can tell what makes this equal to 0 because if two things multiply, because that's what this is here, is x plus 12 times, sorry, I have something in my throat, 2x minus 10, then one or the other has to be 0. You can't multiply a bunch of stuff, blah, 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 and get a 0 out unless there's a 0 in there somewhere. So what this means is we know that one part must be 0. It's either the x plus 12. If not, it's got to be the 2x minus 10. Well, what makes x plus 12 equal to 0? And that would be if x were negative 12. What makes 2 times x minus 10 equal to 0? And you can do that with common sense. You can do that by actually setting it equal to 0 and say, what makes 2x minus 10 equal to 0? Well, I'd add 10, so 2x would have to be 10, divide by 2, and then I get a 5. Or some people just look at it and say, well, it's got to be a 5. Doesn't matter. You're going to, for the final, it's going to be multiple choice, so you're just going to have to make sure you know to figure out what makes each piece equal to 0. How you do that is completely up to you. And then a little review of factoring. What's factoring? It means to break it apart, kind of like unfoiling. So first thing we need to do is figure out, well, if I FOILed to get 2x squared plus 13x plus 6, what could my first terms have been? And there's only one option. The only way you can multiply to get a 2 is if you do 2 times 1. But there's x's there, so we have to have 2x times 1x. So 2x and 1x is the only possible way I can lead this problem. Now remember, this comes from O and I combined, and this comes from multiplying your last terms. So when I'm looking at those last terms, I can either end it in a 3 and a 2, or a 6 and a 1. You've been doing these enough where the 6 and the 1 should be shouting to you because you know you're trying to combine to get a 13. So if you could put this 6 over here on the outside so that when you do FOIL, the outsides will give you a 12, and put the 1 on the inside, and we've been doing that enough where I shouldn't have to go through the entire process. But remember, you can always check these, which is beautiful, especially if you're going to be doing multiple choice. Why not? Just go ahead and check your answer by foiling. So let's just do that really quickly. Suppose you decided that this was the correct answer. Before you go circle it, you might want to FOIL. 2x times x is 2x squared. Score! Outside, 12x. Inside 1x, they add up to 13, so another hit there. And last gives me 6. So I know I've done that correctly. So next, on to something a little new here. Remember that a radical is really just a fancy name for that root symbol. And we are going to be adding and subtracting them. So before we do, let's take the radical away and talk about what's 3x plus 5x. Well, 3 plus 5 is 8. You might say, well, x plus x is x squared. No, it's not. All right? So when we have 3x's plus 5x's, it's kind of like if you have 3 apples and 5 more apples, you have 8 apples. You don't have 8 square apples. So make sure when you're combining like terms, you are simply putting them together. You are not changing them. And that thought process holds when I add the roots in here. 3 root x's plus 5 more root x's gives me 8 root x's when I'm staring at them. Watch. 3 root x's. Step into a room with 5 more root x's. And when I open the door, what do I see? 8 root x's. Notice they don't morph into something else. So to add and subtract radicals, you must have what we call like terms. And in the world of roots, what that means is what's under the root, fancy name for that is called a radicand, sounds kind of weird, has to be the same. So watch. I can say root 5 plus root 5 can be added up, but it is not root 10. It's 2 root 5s. However, a root 3 plus a root 5 cannot be added up. It's done. It's kind of like you're trying to add an x and a y together. You can't. They're not the same thing. Now, this is a section where when kids are absent, they come back and they do the whole worksheet really fast and they think, oh, I missed a really easy section. But they do them all wrong because what'll happen is they'll come in, they'll say, what did I miss? And I'll say, well, you missed 10.3. Well, can I have the worksheet? And I'll say, sure. And there'll be ones like this. And they'll do what their gut tells them to do, which is to say, well, that gives me 8 root 10s. And they'll move on to the next problem and be like, oh, that was so easy. I didn't even have to be here. But these aren't the same. And so you can't combine them. So actually, this was done. So you got to be really careful with doing what looks good versus doing what's right in this section, because what looks good is going to get you done really fast, and they're all going to be wrong. So what do we do when what's under the root, the radicand, is not the same? Well, sometimes once you simplify them, they become the same. So I'll just talk through what happened on this one, and then we'll go do a couple more. 6 root 2 is as good as it gets. So that just stayed here. It's just 6 root 2. I can't do that any better. But then what you need to spot is that root 8 isn't simplified. It's got a 4 hiding in it. So what happened here is we broke 8 into root 4, root 2, which is 2 root 2. And now I've got like radicands. So what's happening here is we're simplifying first, and once it's all done, everything actually has a root 2 in it, and those can be combined. 6 of them plus 4 of them gives you 10 root 2s. Knock it down 3 gives you 7 root 2s. So the moral of the story for the addition is going to be simplify any root that you can first, and then try to add them up. But when the radicand is the same, you don't even need to mess around with it. So I highlighted all these here, and the reason I did that is because I want you to notice that those are like terms. It's like having 6x plus 9x. You have 15x. Same with roots. You just add those coefficients out front. You have 15 when you do 6 plus 9, and you keep the root. You have 6 root 11s plus 9 more root 11s gives you 15 root 11s. Do not make that a root 22. And that's where people who are absent today, they're going to hop on the worksheet and they're going to write like 15 root 22 for one like that without even bothering to watch the notes. And they're going to think it's easy, and every single one of them will be wrong. So moral of the story, you have 1 root 3, you remove 5 root 3, that puts you negative 4, 4 in the whole of those. Do not mess with what's under that root. So if this could be paused for just these don't take very long, when the root's the same, it's really easy. It's the pre-algebra equivalent of what's 3x plus 4x, and you'd say 7x. That's what you're doing here. So if the video could be paused just briefly for those two to get done, and then play it again to check them. All right, we're back. So I notice the root's the same, and I keep it. I do not mess with it. 7 minus 8 is negative 1. And usually with multiplication, you don't need that 1 in there, so negative root 2 is a better version, but both are good. The next one, I'm adding root 5s. That doesn't give me root 10s. It gives me lots of root 5s. I've got 5 of them plus 2 of them, which gives me 7 of them. And I'm done. So that's nice and easy. However, when I notice that these roots aren't the same, I don't add them up. I need to see if there's a like term hiding in there. So what do? I simplify first. What does that mean? It means I got to spot those perfect squares. I kind of have to do a search and rescue and get them pulled out of there. Let's create them again. 1 times 1, which is never helpful. 2 times 2, 3 times 3, 4 times 4. They're not memorized, they're created. 5 times 5, 6 times 6, 7 times 7, 8 times 8, etc., etc. These I'm trying to spot living under the root. There aren't any in root 7. Root 7 is done. So that first term is completely done. But in 28, I can see that there's a 4 living in there. So I'm going to break it into, that stays here. Root 28 would become root 4, root 7. This I know, it's 2. So you might even want to go like that and put a little 2 over there. That's really going to be the 4 root 7 that never got cleaned up plus 2 times 2, which gives me 4 more root 7s. Now I can add them up because once I've simplified, I've got like terms. I've got 4 root 7s meeting up with 4 more root 7s gives me 8 of them. Doesn't turn them into root 14s. All right. This last one, they look an awful lot different. And again, somebody who's absent is just going to go 32 minus 18, 14. They're going to stick that under the root, and it's not going to be right. We need to break them down to see if we have like radicands or like terms. So I need to find and search and rescue any perfect square hiding in 32, and I don't look past halfway. And then I see right away 16 is in there. And then I need any perfect square hiding in 18. That one's obvious. And I'm going to go search and rescue them. I am going to say root 32. I'm going to remove the 16 that's hiding in you. And root 18, I'm going to spot that 9. And then I'm going to go clean that up. I'm going to go get rid of everything here that's in the way. The square root of 16 is 4. So that's 5 times 4 root 2s. The square root of 9 is 3. I can sometimes like to go like that with it. 4 times 3 root 2s. So when I get this all cleaned up, let me scoot this on up a little bit here. I've got 20 root 2s, and I'm removing 12 more root 2s. Now I have like terms. I didn't see them at first because I had those perfect squares kind of muddling it up there, making it kind of cloudy. But once I pulled those perfect squares out and I spotted them, it simplified down to like radicands or like terms. So I have 20 of those, and I'm removing 12 of those, which gives me 8 of those. And then you might say, oh, LaRue, there's a 4 still living in 8. I don't care because it's not under the root. So it's done. All right, so let's see, is that the last page for today? Yep, so what you're going to be working on here today, I would like you to do, first of all, on the bottom, let's have you do one of them on your own. So I'm going to write one out here, and I'm going to write you try. Let's do that here. And I'm going to have you try 2 of them just to make sure we've got this down. The 2 types you're going to be working with. And you can either put this on the back of your note packet or if you have room on the bottom or throw it somewhere. But we're going to give you 2 to try on your own. The first one I'd like you to try is negative root, let's say 10, plus 6 root 10. Just go ahead and write it down, but don't do it yet. And then I'd also like you to try this one. I just dropped my pen. Barnacles. All right, so I've got 2. And I think I'll do root 50. Let's do a subtraction. And I'm going to do 5 root 8. I'd like you to try each of those. So again, if the video could be paused, give kids a chance to write these down. Do them when most hands are up, indicating that they're done. If kids aren't doing them, we'll just wait. So you're not going to get the worksheet till you try these. So just do it, dang it. Then we'll correct them. So pause. All right, time to correct these and see how you did. First of all, you should spot when you're adding and subtracting, you need to have like radicands or like terms. So I have them there, so no need to mess with anything. I'd insert the 1 in front of here so I can see that's how many of those I have. Negative 1 of those plus 6 more of those. Negative 1 plus 6 is 5. We just add the coefficients and the root's the same, so I keep it. Raise your hand if you had that one right. Hopefully most hands are up because when the root's the same, life is easy peasy. All right, on the next one, I can't just subtract those. I have to go and kind of search and rescue any perfect square hiding out in each one of these, and then maybe I'll have like roots. Let's go check it out. 50's got an obvious perfect square. If you say 5 and 10, that makes me sad because you take one root you don't know and you break it into two you don't know, and it's not wrong, it's just not helpful. But 25 is in there, so let's go take a look at that. 25 is in there twice. So that's the one I'm going to try to yank out of there, is that root 25 is going to kind of clear up the waters here so I can see if I have some like terms. Root 8, we've had that one a lot, has a 4 hiding in it twice. So now when I clean this up, the square root of 25 is 5. That's why I chose it. And the square root of 4 is 2. That's why I chose it. So I really have 2 times 5 root 2's minus 5 times 2 root 2's. I've really got 10 root 2's minus 10 root 2's. Uh-oh, what's happening here? I get a 0. Well, that seems kind of strange. What that means is these were the same from the get-go. That's kind of weird because they don't look the same. But if you were to go to a calculator and calculate them, you'll find that they are actually the same decimal value. They just look very different. All right, so we are done. You have a good one. Your assignment, by the way, let me go find it here. You're going to be working on, there's a little slip of paper. It's going to say 10.3A on the top of it. But actually, what you are going to work on is, it says page 616, 1 through 29, but that's because these are screenshot out of your book. So I'm just going to make sure I'm giving you exactly the right assignment here. And I am not. You know what? We got to keep going with the notes here. I apologize. I got to give you a little bit more notes here so we can do 10.3A and then 10.3B tomorrow. So I'm going to give you all the notes so you can do everything you need to do. So we're going to move on. I apologize. All right. You know what? I am going to leave it at that. I'm tempted to keep going. It's whether you want more work today or tomorrow. And because I don't want to leave Miss Peterson with a bunch to do, I'm going to keep going for her. All right, so suck it up. We're going to keep taking a few more notes here. Just so she doesn't have to do so much tomorrow. So turn your page in your notes, and I apologize. We are going to continue doing a few more operations. We are going to do a little bit of multiplying, and this won't be very difficult at all. We should be able to cruise on through here because you're going to do what your gut tells you. When there's something out front of parentheses, it's distributed in. When you multiply, as long as both are under the root, you can go ahead and do that. That would be root 60. That's what 10 times 6 is. But on the next one, one's in, one's out. So you just leave it. And then you decide if it's done. How do you make that decision? Are these like roots? No. So you can't add them up. Do they simplify? Root 60 actually does. It's got a 4 in it 15 times. 10's got nothing in it. So when I clean this up, root 4 is 2. I get 2 root 15 plus 3 root 10. And those aren't like terms, so I can't add them up. I just leave it. Don't you dare call it 5 root 25. That would make me sad. Because we can only add them up if those radicands are the same. So I simplified it all down, and then there was nothing more I could do, so I just circle it. If you remember back to when we first started multiplying two binomials, we did FOILing. So that's what we're still going to do. It's just going to be with roots. So watch. I'm going to do my first terms. Root 6, root 6. You might say that's root 36. I'd say yes it is. But what's that? And the answer is 6. You might even want to think of those first terms as being root 6 squared, and they undo each other. Makes it easier so that if you were like doing root 27 times root 27, you're not actually trying to multiply these because it's really the square root of 27 squared. And those undo each other, so you get 27. All right, so root 6 is 6. On the outsides, so again, I'm going to go on the outsides of the binomials. I've got root 6, root 3. They're both under the root, so I get plus root 18. On the insides, I'm going to get a minus 2 root 18. And on my lasts, I get a minus 2, and then again, I've got that root 3, which is just 3. So I'm really just foiling. First, outside, inside, lasts. Now I've got like terms that are going to get combined. So I've got 6 and 1 root 18, down 2 of them, puts me 1 in the hole, so it'll be minus root 18, and then a minus 6. I've got to keep going with this because 6 take away 6 is 0, so these go. And I'm left with negative root 18. And if you did this on a test, you'd get 3 out of 4 points. But I'd like you to understand, somebody blurt out, why is that not done? Blurt it out. And you should be blurting. There's a 9 in 18. So we're going to break that up into root 9, root 2, which is going to give me negative 3 root 2. So really, we're just taking what we know about polynomials that we FOIL when we have a binomial times a binomial. Same here. When we in a last chapter had like x plus 4 quantity squared, we would expand it. Well, we're going to do the same thing. It's just going to be with roots. So we are going to take this and say that to square something means to do it times itself. And then I'm going to FOIL. So we're going to expand, and then we're going to FOIL. So let's go do that. First, root 7 is 7. Don't go root 49 because you're just going to get a 7. It's circular reasoning. So on the outside, I've got minus 3 root 7s. On the inside, another minus 3 root 7. And for my last, a negative times a negative gives me a positive 9. I'm going to go combine all like terms. These do not cancel out. They give me negative 6 of those. And I also have 7 plus 9. So however, I'm going to do the 7 plus 9 first, giving me 16. And then on my insides and outsides, they combine to give me minus 6 root 7. Now, be very careful here. So if you tune me out, tune back in. Put a little set of eyeballs by that. Be very, very careful here because it's really tempting to just read this left to right and say 16 minus 6 is 10. But it's not 16 minus 6. It's 16 minus 6 root 7s, and those aren't like terms, so it's done. All right, so be very careful. That's a common mistake we see is taking that one too far. It's done. So although it says you try for these, because I've made kind of a long video here and I want you to get to the homework, I'm going to go do these ones with you. So let's go really quickly. What do I do when this is outside? I distribute it in. Gives me root 12 plus, not root 10, because one's in, one's out. So I write it that way, out, in. There we go. What do I do then? I make sure it's simplified. Is there anything hiding in 12? You might say 6 and 2. Sure, but that's not helpful. 4 and 3 is, though. So I'm going to make that root 4, root 3, plus 5, root 2. Root 4 is 2. 5 root 2 is done. Now, do I go any farther with this? And the answer is no. And again, this is where I said it. Kids who are absent, they really do screw this section up because they do it looks good. And they'll add the 3 and the 2 under the root and say it's root 5. But those aren't like radicands, so you cannot combine them and it's done. All right, let's go take a look. What do I do with one like this? I expand it. I do it times itself, so I'm just going to write another one right next to it. So go ahead and do that. And then once it's expanded, I do my FOILing method. My first, outside, inside, last. Let's go do that. First, root 11 is 11. Outside, minus 2 root 11s. Inside, minus another 2 root 11s. Those can't get multiplied because one's out, one's in. And then my last, a negative times a negative gives me a positive. Now I combine everything I can. 11 plus 4 is and always has been 15. And on the inside here, I've got like roots. So I'm down 2, I go down 2 more, I'm down 4 of those. And I put it in a box, and I make sure I don't do 15 minus 4, because that's not what it is. The rule of order says the 4 gets multiplied by the 11. Please excuse my dear Aunt Sally. before that subtraction gets done. So that one is completely done. Let's go do this last one up here, and then we'll be done. And Miss Peterson can come back, and basically you should be able to just have a work day tomorrow, maybe with a little discussion beforehand, but here we go. What do? I've got a 2 by 2, I foil it. What does foil stand for? It stands for first, outside, inside, last. So let's go do that. First terms, if they're both in, I can multiply them. So 4 is on the outside, but root 6 is root 18. There's my first term. Outsides head to the outside of each. I've got 3. And then under the root, I've got root 6, might say root 36, which is great, but root 6 is just 6. So those outside terms just give me 3 times 6. The inside terms are going to give me a minus 8 because of the 2 times 4, and root 3 is 3. So you just have to be really careful here, but nothing's really difficult. My last terms, one's negative, one's positive, so I have minus. 2 times 3 is 6, and both are under the root, so again I have root 18 again. And now I'm going to clean this whole thing up. I've got 4 root 18s minus 6 root 18s. So I am 2 of those in the whole. I've got 18 minus 24, which is negative what? 6? You might say, all right, done. Pass out the assignment. But again, raise your hand if you know why this is not done. Blurt it out. You should be blurting. I don't know if you guys are blurters, but my classes are, and I kind of like it. So go ahead and blurt it out. Why isn't this done? You should be saying, there's a 9 in the 18, or the 18's not done. So we're going to go keep that moving along. That's going to be root 9, root 2, minus 6. You got to spot those perfect squares hiding in there. It's kind of like with fractions. You would never leave 5/10 because it's not done. Well, you never leave root 18 anymore either because it's not done. Root 9 right here is a 3. So we've got negative 2 times 3, negative 6 root 2's down 6. And at this point it's done because they are not like terms. So now I'm done. Sorry about that. I was going to be done earlier, but I think I'm just going to take care of most of the notes. So when Miss Peterson comes back, you can show her how much you know and just do a couple maybe on worksheet 10.3b and then have a work day. So your assignment for today is that little slip that says 10.3a. It's 9 through 29. You're going to do them on a separate sheet. There's obviously not enough room on that little slip. So you have about a half an hour to go ahead and work on 9 through 29 on a separate sheet. They're going to start off kind of quickly. Like on number 9, it's just root 5 plus 6 root 5. There's no work you can show. So for a little while, you're not going to be showing any work. But then once you hit number 13, the roots aren't the same. So you're going to have to simplify that root 63. Got to spot a 9 in there and pull it out. So for 13 through 20, you're going to have to simplify those roots first. Once you hit 21, you're going to, and hopefully the sub has passed out this little slip. So if not, pass it out now so they know what I'm talking about here. But on number 21, 22, 23, 24, 25, all of those, you're just going to distribute. You're going to hop what's outside of the parentheses in. When you hit 26, you're going to expand it and foil it. And 27 and 28 and 29, they're all foiling. So that should go pretty quickly for you, even though I talked a lot today. Sorry. Done.